Hi everyone, my name is Thomas Kim. Today is 23rd of January 2019. This is my 26th episode about template metaprogramming. In this session, we will learn why we should not use type ID in C++ 11, 14, 17 standard. And we will also learn how to demangle type name in C++. Type ID, this keyword is introduced in C++ 98 standard and it hasn't been updated or upgraded to C++ 11 or C++ 14. So type ID in C++ does not work for modern C++ language. So please do not use type ID. I will detail why we should not use type ID in modern C++ programming, and I will also explain how to demangle type name in C++. If you haven't watched my previous video about template metaprogramming 18, please click this link. From this video, show more, then click this link to download the source file. We'll be using this type library that I developed by myself in our previous sessions. Using this type library, I will help you understand more about type information in C++. When download is completed, please unzip it. We'll be using this file shortly. We will be also using lastest version of GNU C++ compiler. If you haven't installed G++ compiler or latest version of Microsoft compiler, please double click this link and install latest version of GNU C++ compiler or Visual source code. Without further ado, I start Visual Studio Code. I create a folder 01 type information, enter. I created a folder type information. Then I create a file type info cpp, click enter. Then I created this file. We will first learn how to demangle type name. Include iostream, include type info, include string, include type traits. Then I create a function, template type name t std string type name return type id t name. It returns type name int main, int I would say int n 5. Then we call this function std cout type name. Then we have to provide a type of n, decl type n std and there. Okay, Ctrl S to save file. Then I move to this folder. I'm currently in this folder dir. So this is the file G++ std C++ 14 or above. It can be 17, for example. Type info cpp out gexe. Control enter, enter. Okay, it built. So gexe. I is displayed. This is mangled type name. We need to demangle this type name. If def gnu g else and if end of GNUG. Okay, we need to include cxx abi.h I'm creating a function std string demangle constant character pointer tname. Tname means type name. I create another here. In this case, return tname. This is for GNU case. int status -1 using pre-t decl type std pre keyword decl type is introduced to C++11 standard. This keyword returns the type name of an object. Okay, so we are getting type of the free function free. We need to include one more file. Include stdlib. We also need memory. Include memory. std unique ptr character pre-t reference or pointer, doesn't matter. demangled name. ABI 2 underscore cxa underscore demangle. We are providing this type name constant character string null ptr then status. We are providing this integer address, then std free like this. At this point, return status equals 0. It means it is successfully demangled. Demangled name get else tname. So we created this function. I will change it into inline. Also here inline. Now we will be using this function demangle here. Demangle like this. Now let's try to build it. dir g. Okay, now the type of n is called to this function. Then it is this type name is retrieved using this function demangle. Okay, so this is indirected. Once we called this function type name, then this type name calls this function. I hope you understand this concept. Please note that we are using type IDE. We are using type ID keyword or operator, type ID operator. This is operator. This operator was introduced to C++ 9A standard, which is obsolete in modern C++ language such as C++11 standard. So this type function does not work. I will explain why it does not work. I think I have to fix this macro GNUC like this, and also here GNUC. Save. Then here I create two functions. Template type name t void decayed type name. t b. I will add one more parameter here, constant character msg, then here std cout msg type name. We are calling this function like this, decl type b. If you don't like this syntax, then we can use using statement type b t like this. We are defining a type name, decl type, then b. We can define type name like this, then copy this, then we provide it here. I think this is simpler. std and there. In C++, the type t is decayed. In C++, the parameter type of t is decayed by default. So in this case, it is not referenced, t is not referenced, so the type of v is decayed. And I copied the same function. Now I put it reference and I change the name undecayed. In C++, type the parameter type of reference t is not decayed by default, not decayed. I hope you understand this concept. This is reference, so in case of this reference type, this is not decayed. Now we try these two functions like this. Decayed type name, decayed type n. I am calling this function here. Please note that I am calling this function decayed type, undecayed type, undecayed type n. Okay, now we build G. Please compare this result carefully. Please note the decayed type. In this case, the type of V, in this case, V is int. Okay, the T is type int. The type of V is int, integer type. In this case, the type of V, should be integer reference, but this reports wrong type. This is not integer reference. This should be integer reference. So this is wrong. This is correct, but this is wrong. In this case, this is wrong because the type of V should be reference, integer reference. This is wrong. Here we are calling this type function, in this type name function, we are calling this type name function. We are using type ID operator. We are using this operator. This operator is introduced in C++ 98 standard, but decl type, this is also operator, is introduced in C++ 11. Decl type operator returns the type of an object. This operator was introduced to C++ 11 standard, but type ID operator was introduced to C++ 98 standard and is not updated to C++ 11. The conclusion is that we cannot use type ID with decl type. I hope you understand this point. The result is very important. Please note that in this case, the type int here, the type of V should be integer reference, but type ID reports as int, so it is wrong. This function is wrong. Now let's try another one. std cout std bool alpha std cout. We can test the type of b like this. std is same int decl type b. So we are comparing the type of b with int std and there. So let's see the result. We build once again. I missed here value. Now build once again. So the result is false. This is wrong type, wrong report. This reports as int, but the result is false. So the type of b is reference here. So it does not work. If we want to fix this problem, please understand the type of b is integer reference. So we have to fix like this. Then we build once again. Then G. Now it reports true. So the type of b is integer reference here. If you haven't downloaded source code from my previous video, please click this link to download type library. Then here, I will copy this file, and paste it to our working folder. Here, I paste it. Then in Visual Source Code again, this is the file. I will include it now. Include talk play fun type name. Now here, please note that this function reports wrong message. Now I copy once, then I change it like this. Talk play fun get type category, then we provide v like this, and correct report, and I also modify like this, wrong report. I modified like this. Now here we build once again. G. Please understand that now this function correct report, this function get type category function reports correct type as integer reference. This is wrong report. This is wrong report like int. So this is the correct way we figure out the type name of an object like this. For your reference, there is another function std cout msg. You can use type talk play fun get type name. In this case, you have to provide the type t, for example t. Okay, then say the type of t std and there. Now I modified like this. Then here I will build once again. G. So the type of t, please compare it. The type of t is int, and the type of v, this v is integer reference. So my point is that you cannot use typeid operator in modern C++ if you want to use it with type decl type. Using these two macro functions, you can find out correct type. Now let me explain what is type decay. In C++, type decay, two conditions should be met. First condition, the template parameter type should be non-reference type. The template parameter type should be non-reference type. So in this case, the template parameter v is non-reference. So the type decay occurs in this function call. And in this case, the template parameter v is reference case. Since the template parameter t is reference, the type decay does not occur. Understanding this point is very important. The second condition, type decay occurs for array and function types. So these two conditions should hold, and keyword auto also participates in type decay. I will give you more concrete examples. So I will disable these for the time being. I create an array. This is one-dimensional array. And I also create a function here. I will create a simple function. Now we created one function and one array. Now we are calling these two functions. I will call this function and I will also call this function. Decay type name A is array, A's decayed type A is array. Okay, so undecayed, A's undecayed type A. Okay, now let's run these two functions. I rebuild and run. Please watch it carefully. A's decayed type, this is array. Now we have to watch these two code. In case of decayed, A's type becomes pointer, integer pointer. Okay, A's undecayed type is the integer array. This is array. A's undecayed type is, so this is wrong. This is wrong. This code is actually wrong. I explained why this is wrong. So wrong, don't pay attention to wrong type. This is wrong. This is correct. Okay, I will disable it. This is wrong, so I will make it correct type. std cout msg talk play fun get type category v. This is correct. And also here, this is incorrect, so I will disable it and I don't need it. So I will build once again cls g. So A's decayed type is integer pointer. A's undecayed type is int array reference. Okay, so in this function, this type of A is array is decayed into pointer. Okay, array is decayed into pointer. In this case, this is template parameter is reference. The type of A is undecayed. In this case, this is undecayed. Okay, I will put some message here. The type of A is decayed to int pointer if it is passed to template parameter t. Non-reference. The type of A is not decayed if it is passed to template parameter as t reference. Okay, decayed type name sums decayed type sum we are passing function, this function undecayed type sums undecayed type sum. Now let's run this function again. I build again A. See, when we pass the sums decayed type this is function pointer. Sums undecayed type this is reference. Okay, function reference. So this is undecayed type, this is decayed type. I will summarize it here for function. The function sums decayed type is int pointer int when passed to a template, when passed as a template parameter t. The function sums undecayed type is int when passed as a reference template parameter or t reference. Now we can display sums type like this: std cout function sums type. Here we can say talk, play, fun, get type category sum. It returns sums type. And there. Now let's run once again. CLS-G. Okay. Function sums type is int. This line of code is returned. So when we pass the sums function sum as to this function as parameter t, then it becomes decayed. Okay. Then this is decayed type. This is as a function pointer. When sum is undecayed and passed as a reference, then it becomes a function reference. So this is sums type. This is sums pointer type. So this is sums undecayed reference type. Understanding type decay is very important in advanced template metaprogramming. Finally, let's see another example of type decay. Auto, I would say AA, A, and auto reference AR, A. Let's try to build this first, if it's working. Okay, it works. Now let's display std cout AA's type talk, play, fun, get type category AA, std, and there. And I copy once again AR's type AR like this. Now I build G. Please note that AR in this case A is array and AA's type is integer pointer. And when we take as reference of A, then the type is not decayed. Okay. Keyword auto also takes part in type decay. And we can try another one, auto SA sum, auto SR sum. Okay. Now we can print out the same way. I copy these and paste SA's type SA, SR's type SR. Then we build CLS-G. So let's see, SA's type is int function pointer. This is pointer. So in this case SR, this is function reference. So SA's type is int, pointer int, because auto also takes part in type decay, whereas SR's type is int reference int, because auto reference does not take part in the type K. Understanding these points are really important in advanced template metaprogramming. If some points are unclear to you, please leave your questions and comments. Please subscribe to my YouTube channel. Thank you for watching.